Hi everyone, welcome to Cola Teaches Math. So today we're going to talk about exponential integrals. And remember I said we always want to chat about a goal. So the goal for exponential integrals, well, first of all, here's the rule in blue. So the integral of e to the u is e to the u plus c. And your goal is to make all of your integrals, when we do them, if they're basic exponential integrals, is like what I just highlighted in blue. And u is going to be the exponent, because you're going to want to take note on what I keep letting u be. And we'll do a graphic organizer on that later. So if u is going to be the exponent right now, I'm going to just highlight in blue all of the exponents. We'll chat about number 3, how there's multiple exponents. And we're going to go ahead and do our u sub. So if u is the exponent, then u is going to be x squared. Du is 2x dx. And dx is du over 2x. Pretty blue brackets. And we're only going to plug in for what I circled, because this other x is going to cancel. So now we're going to have x e to the u du over 2x. The x's are going to go away. We're going to bring that 1/2 in front. So we're going to have 1/2 integral of e to the u du. Oh, I reached my goal. My goal is to have e to the u. E to the u integrates to itself. We have that extra 1/2 in front. So this is going to be 1/2 e to the u. I'm going to replace the u right now, plus c. Done. Okay? All right, next. Same thing. Let's u equal tan x. This is why you have to have your trig stuff memorized, because you need to know the derivative of tan x is secant squared. Dx is du over secant squared x. And now we're going to plug in only for what I circled. So we're going to have secant squared x e to the u du over secant squared x. Goodbye, goodbye. Oh, I reached my goal. E to the u du. This integrates to e to the u. So this is just going to become e to the u tan x. I'm replacing the u at once plus c. Guys, it's a little trick here. I'm not sure if you're not understanding, but realizing that this thing I'm giving you in yellow is almost the derivative of what's in blue. It's usually just missing a constant. Like the derivative of this blue right here is 2x. It's missing the 2 in front. The derivative of this blue right here is secant squared. And then the derivative of this blue right here is going to be what's in yellow. So you don't need to do the u sub. You can do it in your head. However, I like to show it because some kids really like a nice process, a nice procedure. So we're going to let u equal the blue e to the x. The derivative of e to the x is itself. Remember, you recopy the e to the x times the derivative of the power, which is just 1. And then dx is going to be du over e to the x. Okay, so we're going to only plug in for what I circled. We're going to have e to the x, e to the u, du over e to the x. It's a great question. Shout out to someone in my class who said, are we going to do this? And then it popped into my head. Thanks, Jordan. So now we're going to cross out the e to the x's. And we reached our goal. The integral of e to the u is itself. So we're going to have e to the u. I'm going to replace u plus c. Aren't these fun? I love anti-deriving. Okay, bye.